Last time, you closed back doors by adjusting. So adjusting means safety, right? More control, more rigor. No, this lesson is about the opposite failure, conditioning that creates bias out of nothing. The villain is the third pattern, the collider. And it does not only live in regressions. Every restriction, every dropout, we analyzed only the patients who, is conditioning. Adjustment is not a safety operation, it cuts both ways. The collider, two arrows crash into one node and the path is closed by default. But condition on that node, restrict to it, stratify on it, put it in the model, and the path swings open. You already know the intuition, it is called explaining away. A test fails for two reasons: the code is broken or the test environment is flaky. Independent causes. Now look only at failing runs. If I tell you the environment was flaky, a code bug just became less likely. Among the failures, the two causes are now associated negatively, and neither one causes the other. The clinical version. Suppose there are two ways into the cardiology ward: a heart attack scare or severe muscle aches, the pill's signature side effect. You study. Does the pill cause muscle damage? Using ward patients only. Ben is on the pill and his heart is fine. He was probably admitted for the aches. Anna is not on the pill. She almost certainly had the heart scare. Inside the ward, pill use predicts aches and predicts away heart trouble. A pure artifact conjured by who walked through the door. This is Berkson's bias, documented since 1946. And notice, nobody adjusted for anything. The inclusion criteria did the conditioning. That is the general disease. Selection bias is conditioning on a collider that decides who is in your dataset. It wears 4 costumes. Inclusion criteria, the ward-only study. Lost to follow-up, Maria's aches push her out of the study, and so does worsening health. Analyze the completers, and you have conditioned on staying. Volunteering, the health-conscious both sign up and adhere, and surviving long enough to be sampled. Hold that one for lesson 8. The test is always the same question. Is being in my analyzed rows a common effect of treatment and outcome? If yes, you opened a collider. And unlike confounding, which exists before you touch anything, selection bias is created by the analysis, which means your protocol can prevent it. One last trap, aimed at your safest rule. Lesson 3 said, adjust for things measured before treatment. Here is a pre-treatment variable that wrecks you. Health insurance, childhood family income, unmeasured, shapes insurance, and the habit of getting checkups. Genetic frailty, also unmeasured, causes heart attacks, and through early life illness, also shapes insurance. So insurance is measured at baseline, before any pill, and associated with both treatment and outcome. Your reflex screams, adjust for it. But trace the path. Pill back to income, into insurance, out of frailty to heart attack. The arrows collide at insurance. The path is already blocked. The correct adjustment set is empty. Adjust for insurance anyway, and you open the path. Bias you can never fix, because both ends are unmeasured. The shape is called M-bias. Timing is a heuristic. The graph is the law. The rules of modules 1 and 2, collected. Draw the DAG. Every common cause, measured or not, plus everything your design conditions on. Close every open back door. Never condition on anything downstream of treatment. Not by adjustment, not by restriction, not by definition. And before you ask what a study adjusted for, ask what it conditioned on. Your homework, pick any published observational study and list its hidden conditioning. Who got in, who dropped out, who survived long enough to enroll. Next module, Time 0, where observational studies go to die. See you in Lesson 7.